Hello everyone. Today we are going to learn about the angle of elevation and the angle of depression. In trigonometry, you are going to find many questions, problem solving that involve the angle of elevation and angle of depression. So what are they? Now here, so you might have learned that if the angle goes upwards, it's called the angle of elevation. If it goes downwards, it's called the angle of depression. So where is this angle? How does the angle go upwards or downwards? So I am going to explain here so that you can see the difference between when the angle goes and how it goes upwards or downwards, angle of elevation. So you need to know where the observer is. So have a look at the question and identify where the observer is. It's usually where the question says from somewhere in the question. For example, if the observer, so I'm going just to draw the eye here. So we have the observer here is somewhere, and this is where the ground level is, okay? Right, so this is where the observer is, standing up. And he's looking at, let's say, at the sky, at an airplane, at an object on the sky, okay? Object at the sky here, just like there. Now, where is the angle of the elevation? If the angle goes upwards, now to draw the angle of elevation, the first thing you need to do is to draw a horizontal line with the ground, okay? The horizontal line. So this is where the majority of the misconceptions happen. So draw the horizontal line with the ground, and then from the observer to the object, draw a line, just like that. And the angle of elevation is here. So you look straight ahead and then you lift your head upright. So look straight ahead, draw a horizontal line, an imaginary horizontal line with the ground, and if you look up, that is the angle of elevation. So this one here is the angle of elevation. Let's call it E, angle of elevation, all right? And the next case, I'm going to use exactly the same picture, and my observer again stands right here, but right there. But this time, actually, the observer is going to look, so I'm going to draw it so that it looks down. It's going to look down. It's going to look down. It's going to look down at a coin, for example, on the ground, on the floor. Okay, right here, at an object on the floor. Right, again, the first thing you need to do is to draw a horizontal line. That is the key. Draw a horizontal line, okay, right there. And then another line goes from the observer to the object down on the floor because he's looking down or wherever he's looking. If he doesn't look down on the floor, anywhere down, okay? It should be a straight line, please use the rulers. So the angle of depression is going to be this one here, right here. And I'm gonna call it a D. Can you see? So the angle of depression is the angle that is created by the horizontal line and the other line that joins the observer with the object. Okay, so you look straight away, that is the horizontal line, and then you look down, that angle makes the angle of depression. And you look up, again, from the horizontal line, that angle makes the angle of elevation. So this is what it is, so upwards and downwards. Let's have a look at an example here. It says the angle of elevation of the top of a cliff from a boat, I'm saying here on the steps, underline the one from. So this is where the observer is, from a boat, 125 meters away from the bottom of the cliff. So, okay, so you have a boat and a cliff is 35 degrees and it's the angle of elevation. The boat, so let's draw the boat. So this is where is the CSAT label, right? And the boat is somewhere here. Okay, this is where the observer is, somewhere here, and the boat is 25 meters away from the bottom of the cliff. So let's suppose the cliff is somewhere here. Okay, there it is, right there. And the distance from the boat to the cliff here is going to be 100. All this is 125 meters. That's what the question says, 125 meters. And you see, the cliff at about 25 meters. So from the bottom of the cliff is 35 degrees. So the angle of elevation is 35 degrees. So how do you draw this angle of elevation? It's from the boat. Here's the boat, somewhere here from the boat. So the horizontal line is right there. The horizontal line goes like here. And the other line that joins the top of the top of the cliff. So this is where the object is. So the observer that is on the boat looks at the top of the cliff. That is right there. So this is the angle of elevation, okay? Right here, angle of elevation. And this angle here is 35 degrees, 35 degrees, just like that, okay? And obviously this distance here is 125 meters away, because them two is the same thing. So now in terms of finding out, this is 125 meters, find the height of the cliff, which means we need to find the distance is from here, from the top of the cliff, and here. All this is the height. I'm going to label it as a h. Okay, so can you see? This is the height. That means this angle here is a right angle. So after I drew the angle of elevation, actually, can you see? I'm ending up with the right angle triangle, and h actually is the opposite side of the angle of elevation. And I have the adjacent as well, 125 meters. That means I can apply the tangent ratio. So I'm going to have tan 35 equals the opposite side in this case is h, the h over 125. Over 125. This is just an equation. Now let's find to find tangent 35. So you are going to need a calculator, and then so press tan 35 equals, and the answer is 0.7, roughly 0.7. So 0.7 equals h over 125. Now here we have a simple equation with the denominator, a number in the denominator. How to get rid of the denominator? By multiplying both sides by 125, just like that. 125 times 125 on this side. Okay, just like that. And so we have 0.7 times 100, 0.7. So 0.7 times 125. The answer is going to be 87.5. So 87.5 equals the h. So I did this multiplication straight away. So them two together equals h. 87.5. Actually, the measuring unit is very important. Or h equals 87.5 meters. Just like that. See how important it is to build, to draw the problem carefully, and to understand the angle of elevation or the angle of depression, because that makes it is crucial when you solve the equation involving tangent ratio, or maybe in the future doing sine and cosine questions. And so well done for watching my steps, and have a lovely day. Bye-bye.